In this video, we're going to be talking about the box and whisker plots and the 5-number summary. We are only talking about the box whisker plots up till now because we needed the information about dispersion and also about quartiles. So a box plot summarizes data using the mean, the upper and the lower quartiles, and the extreme, the least and the greatest values. So we're talking about the range here. We're talking about a central tendency measure here. And we're talking about also quartiles. It allows you to see the important characteristics of the data immediately because it is a graph. It is especially useful for indicating where a distribution is skewed. Remember, skewed is if it's not like right in the middle or normally distributed, and whether there are potential unusual observations in the data set. We need first to get the 5-number summary before we start drawing our box and whisker plots. So the 5-number summary is the median or the second quartile, the first and the third quartile, the maximum value in the data set, and the minimum value in the data set. So with those 5 numbers, we're going to construct our box and whisker plot. This is how the box and whisker looks like. So in this case, we have the lowest value. If you see, it is our starting point of a whisker. And the highest value, it is the ending point of my other whisker. We have the lower quartile, so the Q1 and the Q3 making up my box. And the median is shown here. So for example, I can see here that my median does not fall in the middle. So in this case, my data set is a little bit skewed. So how are we constructing a box and whisker plot? So for example, we have this data set. So we have 3, 6, 9, 12, 15 data points. So we have 15 data points. Because we need the median, we will put it first in order. So here I have my 15 data points in order. So my median, if I have 15, means 7 and 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that means that my median is 68. So now we need to find the lower or the first quartile. I told you that this is position, right? So in this case, we have 0.25 n plus 1. So we have 1 over 4. We have 15 plus 1. So we have 16 over 4. So this is equal to 4. But the 4 is position. So I have 1, 2, 3, and 4. That is my Q1. So now I need the Q3. I know that the Q2 is the median, so I already got the median, right? So the Q3, it's going to be 3 over 4. 3 over 4. 15 plus 1. So I have 3 times 16 over 4. That is the position 12. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this point is my Q3. All right. Another way of looking for Q1 and Q3, it's also the median of your lower part of your data. If you see, this is the midpoint, and the median of your upper part of your data. You can either do that or do it with the formula. So we find the minimum and the maximum. So the minimum is 18. The maximum is 100. And we also find the interquartile range because that's going to be how long my box and whiskers is. So I had a Q3 of 87 and a Q1 of 52. So that means I have an interquartile range of 35. That means how long my box is going to be. So now that I have my numbers, I just organize them. I have the median 68, the lower quartile 52, the upper quartile 87, and the maximum and the minimum. So now that I have that, I'm ready to draw my graph. So in this case, I can have something like this. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So now I know that the minimum is 18, so that's my start of my whisker. I know that my Q1 is 52, so that's the start of my box, so around 52. The end of my box is going to be at 87, so somewhere over here. So this would be 87. So that's my whole box, right? So that's my box. Now my maximum is 100. So my other whisker is here. So I just take it into the middle. And now what I need is my median. So my median is 68. So it's going to be somewhere here. So I have my median, my Q1, my Q3. This is my interquartile range. This is my lowest point. This is my highest point. And if you see from here to here, it's my whole range. So actually, once you have the 5-number summary, the box and whisker plots is very easy to graph. So what do we do if we have an even number pieces of data? We saw this before. So in this case, we have 5, 6, 7, 8, 9, 10. We have a data point of 10, 3, 5, 3, 5. So in this case, actually, my median is going to be here. So my median, it's going to be the average between these two, right? So that also means that my quartiles are going to be the average of the middle two numbers, right? So it splits the data set in half. So now I put it there, and this is my Q1, and this is my Q3. So in this case, my lower quartile is 5. My Q3 is 11. My maximum is 20. My minimum is 2. The range is 18, right? So I can do a box and whiskers for this also. So how do we graph the data again? So we start with my lower extreme and then my upper extreme. This is going to be how my range is. I then start with my lower quartile, that is the start of my box, and then my upper quartile. Remember, this is the interquartile range. This is how long my box is. Then I graph the median, and then I just have my box and whiskers. How do you interpret the graph? So the range or the spread of the data and what it means to the graph. If we have a very large range, that means that my data is not behaving. Is that good or is that bad? Depends on what you're talking about. I would think that a large range in temperature in January is something bad because temperature in January is usually very cold, but it's very cold throughout the month. We don't have 30 degrees and then 10 degrees and then 35 degrees. So depending on what you're talking about, a large range or a small range is good or bad. Quartiles, what are they telling you about your data? Again, if your quartile or if your interquartile range is very large, that means that your data is not behaving. The median is an important part of the graph because it tells you what your midpoint is. When we were talking about the salaries of sports figures in sports team, I think that a better description of the salary would be the median, because the median does not care about outliers, about those people that are earning a lot or very little. And percentages should be used to interpret data where relevant. We saw this with the pie chart. We use pie charts so much because percentages just make sense in our heads.